Hello again. Welcome to another lesson in Algebra 1. Today we're covering section 8.4 on scientific notation, but we're also going to pick up the topic Pythagorean Theorem so we can do some simplifying with radicals. Okay. So a number is scientific notation when it is in the form of c times 10 to the n power, where c has to be a number between 1 and 10, not including 10. And n is an integer, so we could have positive or negative whole numbers up there. Okay, so it's used to write numbers that are very large, very small, or very close to zero in a more readable, compact format. So you use this in science a lot, which is why it's called scientific notation. So here's an example. Maybe you need to write 2 billion. If I write 2 billion, that's a 2 with 9 zeros, and the 9 zeros don't really tell us a lot about the number. So we could change that to 2 times 10 to the 9th power. Okay, and then when we write it in a textbook or in a reading for a paper, scientific paper, we can make it a lot shorter. Okay, or maybe 7 thousandths, so that's 0.007. This zeros in front of the 7 don't tell us a lot about the number there, so that's really just 7 times 10 to the negative 3 power. Okay, so whenever you see a negative exponent, you know the number is really close to 0. And whenever you see a positive exponent on the 10, you know the number is either really big or really small, depending upon the sign of it. Okay. All right, number 1, 267,500,000. We want to write this in scientific notation. So we change this to 2 point, and let's see, we have to pick up the decimal and move it between the 2 and the 6. So 2.675 times 10 to the, and that's 8 moves that we made, so 10 to the 8th power. Okay, so 2.675, that's a number between 1 and 10, and then times 10 to the 8, and 8 is an integer. All right. For number 2, we have to pick this up until we get a number and move it until we get a number between 1 and 10. So we'll move it between the 4 and the 8. So this will be equal to 4.86 times 10 to the, and let's see, we moved it 1, 2, 3, 4 spots, but we moved it to the right, so that's negative 4. The numbers close to 0 get negative exponents. Big numbers or really small numbers get positive exponents. Okay. All right, number 3, we're going to pick up this thing and move it from behind the 0 all the way to between the negative 2 and the 5. So negative 2.5 times 10 to the 9/10th power. Okay, so when I say a number between 1 and 10, I also mean a number between negative 1 and negative 10. So the C in this case is negative 2.5, which falls between negative 1 and negative 10. Okay, notice we have a positive exponent, so this is a really small number, negative 25 billion. That's a lot. Okay, all right, number 4. 0.0000006. I got to pick up this decimal. I'm going to move it to the right. This is a number really close to 0, so it's going to be 10 to the negative something. We have a 6 now, and we moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 to the negative 10th power. On our second page, the directions say write each number in standard form. So right now these numbers are in scientific notation, so we just want to make them back into normal numbers, which is standard form. So take away the scientific notation part. All right, so we're going in reverse here from the other page. So we're going to pick up this decimal, 2, 3, 4, and we're going to move it 5 times. Now this is a positive exponent, so this is going to make the number be really big. So we'll move it 1, 2, 3, 4, and we add our own 0 to make 5 moves. So then we'll write this nice and neat, 702,340. Please do not write your final answer with a bunch of loops under the numbers, okay? The loops just tell us what to do, and then we write our nice, clean final answer. All right, number 6 here, we have 3.096 times 10 to the negative 6. So this one's got a negative exponent, so we're going to be making this number close to 0. So we're going to have to move the decimal to the left. So 1, 2, 3, 4, 5, and 6. So it's going to be 0 point, and we have 5 zeros there, for 53096. And there's our final answer. Okay, notice once again, I did not write my final answer with a bunch of loops underneath it. So this is going to be 7.5 times 10 to the 7th. So I have to pick up that decimal and move it 7 times to the right to make it a big number. 2, 3, 4, 5, 6, 7. That means I have to put 6 placeholder zeros in there, and that's going to make 75 million. And in our last one, we have a negative exponent, so this is a number close to 0. So if I move this decimal 9 times, I'm going to have 8 placeholder zeros, 4, 5, 6, 7, 8, and then 21. So one move is for the 2, and then I have 8 zeros to make go 1 plus 8 for negative 9 there. All right. So order the numbers 103,400,000, 7.8 times 10 to the 8th, and 80,760,000 from least to greatest. All right, so all of them are in standard form except for the middle one, so I'm going to rewrite that in standard form so I can see whether it's bigger or smaller than these two. So this will become 7, 8, and I got to move it decimal 7 more times, so I'll add 7 more place value zeros. It's 4, 5, 6, 7. So that's 3, 3. So that's going to be 780 million. So that's going to be the biggest one. So my smallest one's going to be 80 million. This is the way it was written, so we'll keep it the same. The next one would be 103,400,000. Let's see. We'll put a big bar between them. So there's the next one. And then our last one is going to be that 7.8 times 10 to the 8th power. Okay, so that one is the biggest. And notice I wrote it back in its original form. When you're asked to order some numbers from least to greatest, you want to order them in the way that they're written to begin with. You not change them, okay, for your final answer. All right, number 10 down here, 11 and 12, we're supposed to evaluate the expression and write your answer in scientific notation. The nice thing about scientific notation is I don't have to do turn them back into standard form to do the operations. So I can do all my operations on this. So I can reorder this. This was really says 8.5 times 1.7 times 10 squared times 10 to the 6th. All right, so 8.5 times 1.7 is 14.45 times 10 to the, and 2 plus 6 will make 8 here. Now the problem is our final answer is not in scientific notation. It's 14.45 times 10 to the 8th. I need it to be 1.45 times 10 to the, and then we need to think about this for a second. So I just made the number get smaller. So that means the exponent on the 10 should get bigger for us to stay equal. Since I made the decimal move 1 time to the left, the exponent will get 1 bigger. Okay. All right, number 11. This one we can use our exponent rules on also. So we're going to do 8.5 squared. This will be 72.25. We'll have to clean that up in a minute because that's not a number between 1 and 10. And then that's times 10 to the negative 6. All right, so since I want this to be 7.225, I made the number 72 get smaller, so my exponent needs to increase. I moved the decimal only 1 time to the left, so my exponent needs to increase only by 1 value. So negative 6 changes to negative 5. All right, and our last one here, number 12, we have 1.2 times 10 to the 4th equals 1.6 times 10 to the negative 3. So we're going to do our division of the coefficients in the front. So 1.2 divided by 1.6 is 0.75. And then we'll do our exponent rules for the base 10 here. So 4 minus negative 3 is going to give me 7. Unfortunately, this is still not in scientific notation. So I have to change this to 7.5. So I just moved the decimal 1 time. Now I have a number between 1 and 10. So I made this number get bigger. So since this one got bigger, the exponent on the 10 has to get smaller. I moved the decimal 1 place, so I changed the exponent by 1. So it would be 7.5 times 10 to the 6th. All right, on our next page, we have a review of the Pythagorean Theorem. So this is a graphic organizer on how to find the missing side of a right triangle using the Pythagorean Theorem. So first step, we have two examples here. We have one example where the missing leg and another example where we have a missing hypotenuse. So remember, write down the lengths of the small sides. Those are the legs. The legs touch the right angle. So here's my right angle. So this is a leg and this is a leg. So my legs in the first one are x and 3. Those are the two small ones. Okay, two small sides. In my second example, the legs are 7 and 5. Okay. Now write down the lengths of the big side. The big side is a hypotenuse. The hypotenuse is always across from the right angle. So I always circle the right angle and draw an arrow across, and that helps me find the hypotenuse, which in this case is 5. And then this one is x. All right, so then we use the Pythagorean theorem for a squared plus b squared equals c squared to write an equation. So the two small sides are added together, and that should equal the big side, as long as everything is squared. So that makes sense. If I'm adding two parts together, I should add the two small parts together to make the big one. Okay? So over here, we're going to get 7 squared plus 5 squared. The two small sides added together equals the big side. And make sure we square all the parts. That's what makes it true. All right? And we solve for the missing piece. So we have x squared plus 9 equals 25. Then we subtract 9 to both sides, and 25 minus 9 makes 16. And then we can square root both sides, and the square root of this is plus or minus 4, but we ignore the negative here because we're finding the length. So the length of this side was 4, and it was millimeters. So 4 millimeters. All right, so in our last one here, we do 7 squared, which is 49, plus 5 squared, which is 25. This time, the numbers are on the same side, so we'll just add them together. 49 plus 25 makes 74. And then we square root both sides. So the square root of 74 does not work out evenly, so we'll go ahead and round this. I'm going to round it to the nearest tenth, so this will be 8.6. So we're just rounding here, so we'll put the squiggly equals to show that this is an estimate. So our side is about 8.6 millimeters. All right, so notice in the first example, we were finding a leg, and our leg was 4, which is shorter than the hypotenuse. So we had legs of 3, 4, and a hypotenuse of 5. In our second example, we were finding the hypotenuse, which was 8.6 about, and that's longer than both the legs. And that's a good check to make sure that you have that. All right, so remember, the legs are the small sides that go into the equation for A and B, and the hypotenuse is the big side that goes for C. So always circle the right angle and find that big side and make sure you put it by itself. All right, let's take the last page here. Okay, on our last page, the top two questions say find the missing side of each right triangle. So what I do is I always circle the right angle, draw to the side across from it so it doesn't touch the right angle. That's my long side or my hypotenuse. So I know my legs in this case are x and 5. If I add them together, I get the long side as long as I square everything. Okay, so now here I've got x squared plus 25 equals 144. And then we subtract 25 to both sides. And we get x squared is equal to, and here I use my calculator, so 144 minus 25 is equal to 119. And then we're going to square root both sides. And when we square root this, it doesn't work out evenly, so we can leave our answer as 119. You'll see that on Khan Academy tonight. Or you may go ahead and round it. I suggest rounding to the nearest tenth at least. So the square root of 119 is about 10.9. So our missing side here is 10.9 inches approximately. Okay, so in our last one here on this directions, number 14, we have our right angle. We draw an arrow across, so the long side is x. So this will become 3 squared plus 4 squared equals x squared. And then we go ahead and work this out. So 9 plus 16 is x squared. 9 and 16 make 25. And then we square root both sides and we get exactly 5. So our answer here is 5 millimeters. No rounding needed. Okay. Number 15. A rope from the top of the mast of a sailboat is attached to a point 2 meters from the base of the mast. The rope is 8 meters long, and how high is the mast? So these are our word problems here. Our first step is to draw a picture. So let's see, here's my little sailboat. Okay, here's the mast. And then we're going to attach a rope from the top of it all the way down to some point that's 2 meters from the base of the mast. So it goes like this. So our mast, of course, creates a right angle. We have a 2 here, and the rope itself was 8 meters long. So we want to see how tall was the mast. So we've written our picture. We're going to write an equation now. So we drew our picture. We'll write our equation. 2 and h are the small sides. The big side is 8. And they add up the small sides equal to the big side as long as I square everything. So I'll do 2 squared for 4, plus the height of the mast squared, and then that equals 64. I subtract 4 from both sides to get 60, and then I'll square root both sides and get the square root of 60. Okay, so we're only looking for a positive distance, so we ignore the negative square root of 60 here. And we'll go ahead and round this. So we'll say that this is about, and I got my calculator here, the square root of 60 is about 7.7. So 7.7, and our units were meters. So the mast is about 7.7 meters. Okay. All right. If the 2 short sides of a right triangle are 3 and 5, then what is the length of the third side of the right triangle? So we'll draw a right triangle, and the 2 short sides were 3 and 5. They are the legs, they touch the right angle, and we want to know what is the hypotenuse in this case. So remember the hypotenuse, the long side's always across from the right angle. So here we're going to write our equation then. 3 squared plus 5 squared equals x squared. 3 squared is 9. 5 squared is 25, and 9 plus 25 makes 34. So x is going to be equal to the square root of 34, which is about 5.8. Okay, so the third side is about 5.8 inches. All right, our last question. A 12-foot ladder is leaned against a wall and it reaches 10 feet up the wall. How far is the ladder from the base of the wall? So here's my wall. There's my ladder. And the ladder is 12 feet. We reach up 10 feet up the wall, and we want to know how far over. So there's our right angle. There's our missing distance. 12 is definitely the long side here, so we'll go x squared plus 10 squared equals 12 squared. And then I'll square all the parts. So 100 and 144. We subtract 100 to both sides, and we're going to get 44 left over. So x is equal to the square root of 44, but we'll go ahead and round that, which is about 6.6. All right, so how far is the ladder from the base of the wall? The ladder is about 6.6 feet from the base. All right, this concludes our notes for the day. There is a Khan Academy that you need to do. Pythagorean Theorem is the name of it. It's due the day, so Khan Academy module, Pythagorean Theorem before the day after our next class. So it's due the day after our next class when you need to have it completed. Okay? All right, I will see you in class next time.